All right, let's take a look. It's certainly an exam, and exams always make people nervous, myself included. I just don't like taking an exam myself. So looking at number 20, it's a rational function. I see the graph. I see the questions. I'm going to hold off on that one. That kind of scares me initially. Number 21, not so scary. Let's write this down. I'm going to make a substitution. I'm going to make u equal to 4 to the x. I'll write this as 4 u squared minus 17u plus 4 equals 0. This looks like it's factorable. 4u and u looks like 4 and 1 minus minus. Does that work? It does. It gives 4u squared minus 16u minus 1u is minus 17u, and you get plus 4. So what does that mean? U could be 1/4 or u could be 4. But I don't want u, I want x. So what do I give here? 4 to the x. Well, 1/4 is 4 to the minus 1, or 4 to the x, which is 4 to the first power. So x is clearly plus or minus 1. Well, let's go back over here and see if it's in there. I do see it. I see the answer right over here. So B, x equals plus or minus 1. Okay, so that's a confidence builder. I got 1. I want to go for more. Let's look at number 22 now, and that's a condensation problem. So I'll write this over here, and it's going to be equal the log base 2, the root of x, plus log base 2 y to the 4th power minus log base 2 of z cubed. All right, next up, I'm going to pull 3 logs together into 1 log. It's going to be log base 2. We're going to have y to the 4th power root x over z cubed. Final answer. All right, let's look at number 23. Looks like a relatively simple question. I'll write them in the same base, by the way. This is going to be 4, 3x minus 5 equals 4 squared, which means 3x minus 5 is equal to 2, which means 3x is equal to 7, which means x is equal to 7/3. Right, now, if I take an exam, I wouldn't check it now. Like, I wouldn't check the other ones, just kind of going through the exam. If I have time, I'd go back and check what I'm writing down, by the way. But anyway, let's keep moving along. Let's look at 24 multiple choice. Kind of like multiple choice, although sometimes it can be very distracting. What do I go here? They say h of x is equal to 3, and it equals log base 2 of x squared plus 2. Well, I'm going to rewrite it so it's not a log, it's an exponential. That's going to be 2 cubed, which is 8, which is x squared plus 2. Subtract 2 from both sides, I get 6. So x would equal plus or minus the root of 6. What would they say? They just want the positive number, and that's going to be root 6. Is that here? Right over here. All right? So far, I'm moving along. Number 25, long division. I'll hold off on that for a second. I'll come back to it. I'm going to look at 26. I'm going to do this one over here. I'm going to, basically rules of logs. Log base 3, and that's going to be x times x minus 8 equals 2. And what do you get over there? Oh, let's rewrite it. You get x squared minus 8x. Then it's going to be 3 squared, which is 9. You get x squared minus 8x minus 9 equals 0. I'm going to factor that. Looks relatively simple. Looks like 9 and 1 minus plus x equals minus 1 or x equals 9. Now immediately what I know is I can't be minus 1, and the reason for that, I get a log base 3 of a number x, and x has to be positive. So I'm going to box this one over here. I haven't checked it yet, but I'm going to box that one. All right, number 27 is an older problem. I would say in Math 119, this is the one thing you should be able to retain when you leave 119, at least this, is to solve an inequality. Let's write this down. So 3x minus 5 over x plus 2. You got to get a 0. So minus 2, x plus 2 over x plus 2, greater equal to 0. Common denominator, x plus 2. You get 3x minus 5. Let's see, minus 2x minus 4. Got some more work to do. This is x plus 2. And you get, let's see, x minus 9. The number line goes down, and on that number line, is where the top takes on a 0 and where the bottom takes on a 0. So at -2 and at 9. At 9, that becomes an equality, becomes equal to 0, and that's good. At -2, it becomes undefined. Pick some test values, like a number after 9 would be 10. You're going to plug it in here, see if it makes any sense, and it does. If I plug in 10, I get positive followed by positive, which is certainly greater than 0. If I took a number like 0, which is between -2 and 9, and plugged it in now, I'd get a negative number, and that's not greater than 0. If I took a number below -2, like -3, and plugged it in, I would get negative 5 by negative, which is a positive, and that clearly satisfies that inequality. What do we get over here? Minus infinity up to -2. Don't touch it. Union 9 off to the infinity. All right, put a box in that. All right, let me go to the last question here. And again, we'll go back over the exam again, and I'll look for things that I haven't done yet. I'm just looking for easy things. Now, I'm going to say that looking at this thing over here, some of these things are kind of ridiculous, and I'll tell you why. If I were to graph down, y equals 2 to the x, that would be a growing problem, all right? Now, I'm going to say these things are ridiculous over here. They're just not working out. I'm not seeing a growing problem there. I'm seeing something decreasing. All right, so I'm going to say those are ridiculous. I wouldn't select those. I got 3 choices now, and these are going to be decreasing functions. They're all going to go down, right? All of them go down. What I'm going to do is something easy, though. I'm going to look for the y-intercept. And what's the y-intercept? It's 4. When does that occur? It occurs when x is 0. Let's check it out. Let's look at this one over here. When x is 0, what do you get? You get 4 minus 1, because a half to the 0 is 1. So this is going to be 3. This one's ridiculous. It's supposed to be 4. Let's keep moving along. Let's look at this one. What do you get over here? You get 1 plus 4, which is 5. This one's ridiculous. It's supposed to be 4. Let's check this one. What do you get over here? You would get 1 plus 3, which is 4. I'm getting it, all right? So I'm going to say this is the good answer over here. The other thing I want to point out over here is that it's kind of easy to look at this and know that as the x goes towards infinity, that this will be asymptotic with the line, and that line would be y equals 3. So it seems to stand to reason, all right? So I'm comfortable with that. Let's go backwards, see if I've answered everything I need to answer. I did 27. I just did it quickly. I did 26. Oh, I didn't do 25. Let's put that down. It's a long division problem. You get x squared. Let's see. Let me get my eraser because I might run into that. And let me write this down. X squared plus x minus 1. And then you get x cubed minus 2x squared plus 3x minus 5. And I'm going to start dividing. So what times x squared would be x cubed would just be x. What does it give you? X cubed plus x squared minus x. I got to subtract now. What do you get over there? Minus 3x squared. And then you get plus 4x minus 5. Let's keep moving. It's going to be minus 3 now. What do you get? Minus 3x squared minus 3x. And then you can get plus 3. What does this give you? Well, it gives you 7x minus 8. What's their question, though? Use long division. I did, but they want me to find a slant asymptote. The slant asymptote is going to be y equals, whoops, x minus 3. I'll put a box in that. And let's keep going backwards. Things I didn't answer yet. I answered that. I've answered that. I'm looking at the boxes. So I got that one boxed off as well. I didn't do this one yet. This is probably the most difficult question on the exam, by the way. So let's take a look at it. And by the way, it's given to you in your homework. You've seen it before. And I'm kind of looking at the picture, by the way. And I'm going to say I could probably write the domain down pretty quickly. And the domain's going to be all real numbers. I'll do some implementation later, by the way. But the x can't be minus 1. And the x can't be 4/3. All right? So I'm going to say it looks pretty easy to do that because they provided the information to put that down. So I'll write this down now. The domain is going to be, and again, I have to be very careful over here. Let's see. I'm going to say minus infinity up to minus 1, union minus 1 up to 4/3, union 4/3 to infinity. I got this covered. All right. Range always scares me, by the way, but I'll come back to that later. That's the second question. I want to do the horizontal asymptotes. And what's it going to be? Limit as x goes towards infinity of f of x. Well, I have to do the other one too, right? The limit as x goes towards minus infinity of f of x. And let's see what happens here. Let's go back and look at it. And I see a picture over here. I know it's somewhere between 0 and 1. But looking at it, remember we said divide by the highest degree variable. And what do I see there? I would see 1/3. I'll write this down for you. 1/3. 1/3. What do you get over here? You get y equals 1/3. I'll put a box in that. Call that a day. Let me do the equation of the vertical asymptotes. And let me put this down. Limit as x goes towards, well, it's nice to have a picture, by the way. And I'm only seeing 1. And what do I see over there? It's not at -1. This is just not happening there. All right, we'll talk about why it's not happening there later. But there's only one candidate now. It's 4/3. All right, put this one down for you. I'll write down the 4/3 from the right of f of x. And I want to write down the limit as x goes to 4/3 from the left of f of x. And let's take a look at that. And from the right side, looks like plus infinity. And from the left side, just looking at the picture, by the way, I'm going to say minus infinity. What does this mean? X equals 4/3 would be the vertical asymptote. All right, range is more difficult. Range is more difficult. One thing I want to point out to you, though, although you can't really see it, at -1 there's a hole. There's a hole there. So I know, looking at this graph over here, that this thing kind of sails up. It never touches the 0, and then it sails up here. Now over here, I'm looking at this over here too. I'm seeing this too. And I hope you realize that this line over here is y equals 1/3. All right? Now someone says, I wonder if it touches the line 1/3. Well, you could write it down. You could write down 1/3 equals, I'm going to put a simpler form down, by the way. I'm going to use this form over here. That these would cancel off, by the way, because we're nowhere near the -1 there. So let's write this over here. So you get x plus 1 over 3x minus 4. This would give me 3x minus 4 equals 3x plus 3. And I hope you realize this has no solution. What does it mean? It never touches 1/3. So I think I'm ready to write the range down now. So the range of it, it's going to be all the numbers. But there's two numbers that are not going to come into play over here. 0 is not going to happen, and 1/3 is not going to happen. They're both not going to happen. Let's write this down. So minus infinity to 0, union 0 to 1/3, union 1/3 to infinity. I'll put a box in that. All right. Now, granted, the exam's done. All right. I would go back over it now if I had time, and certainly if you don't have time, you're done. You just hand the exam in. But if you had time, let's say you finish this in, I don't know, 10, 15 minutes, I would go back and redo every single question again. Every single one I do twice. Right? Not only would I do it twice every single question, I would check all my answers to make sure they're satisfied. All right? Like, for example, I'd take this and I'd plug it in there to make sure that was true. Right? This over here, I would just do it twice. This over here, I'd plug my number in, make sure it works out, by the way. This over here, I'd plug my number in, make sure it works out. I really would. All right? What number talking about? √6. All right, over here, what would I do? I would do the long division again, just to make sure I got what I need. All right? Over here, what I do? I would check 9 in the original equation. Over here, what I do? I would do the problem again. This one over here, I do it again. All right? I really mean that. Again, do it again. All right, thank you for paying attention. Hope you did well in the exam. Most of these questions were taken directly from the notes that are provided to you free of charge. Thank you.